Welcome to the video lecture on indoor air quality management. What is indoor air quality? Indoor air quality is a term which refers to air quality within and around buildings and structures, especially it relates to the health and comfort of building occupants. It refers to the quality of air inside buildings as represented by concentration of pollutants and thermal condition that affect the health and performance of the occupants. What are the contaminants and their sources? Contaminants may originate outside the building to be transported or ventilated into the facility, or they may be generated within the building. While in the building, they have a limited number of options available to them. Indoor air quality is determined by a range of conditions and the interaction of sources, sinks and air movement among rooms and between the building and the outside the building. They have a limited number of options available to them. The primary source of air pollution, indoor air pollution, includes asbestos, insulation, fiberglass, and dust particles. And second source is from the bathrooms, where excess humidity prevails, personal hygiene products like aerosol sprays, etc., and mold spores. And from the home office, where printers, photocopies, volatile organic compounds are liberated from these equipments and causes indoor air pollutant. So lingering odors, bacteria, cooking pollutants from the kitchen and fireplace, dust and dust mites, allergies, second-hand smoke, humidifiers, pet air, carpet, or from the living area. And from the basement, we have high humidity levels, unpleasant odor, mold, carbon monoxide, firewood, solvents, wood stove, dust and dust mites, paint, chemicals, etc. from the basement. And we have carbon monoxide, gas, solvent, pesticide, herbicide, dust, paint, chemicals, cleaning agent from the garage, allergens, dust and dust mites, pet air and dander, carbon dioxide, carpet from the bedroom. So these pollutants are picturized in this simple format. So we have major pollutants like mold, bacteria, pollen, tobacco, mildew, chemicals, pesticides, food particle, dust, and pet gas. Indoor air quality can be affected by gases including carbon monoxide, radon, volatile organic compounds, particulates, microbial contaminants like mold and bacteria. Now we will see different pollutant and its effects. Nitrogen dioxide is the pollutant which causes irritation in the skin, eyes, throat, cough, etc. Carbon monoxide causes headache, shortness of breath, higher concentration may cause sudden death. Respirable suspended particulate matter causes respiratory illness, acute asthma and chronic levels causes lung cancer. Sulfur dioxide gas causes lung disorders and shortness of breath. Radon causes lung cancer. Formaldehyde causes irritation to eyes, nose and throat, fatigue, headache, skin allergies, vomiting, etc. Asbestos causes lung cancer. Pesticide causes skin diseases, and volatile organic compound causes liver, kidney disorders, irritation to eye, nose, throat, skin rashes, and respiratory problems. Ozone causes eye itch, burn, respiratory disorders, lowers our resistance to colds and pneumonia. Managing indoor air quality requires a basic understanding of toxicity and hazard. These terms are frequently used incorrectly in the press. They are not symptoms. Every substance is toxic to the human in some manner or to some degree, even or in juice. A toxic substance becomes hazardous by intensity of the dose, length of exposure, or the manner in which it is introduced into the body. Hazard is actually a measure of risk or the probability that an unwanted event will occur. Hazard is usually measured in severity or magnitude. It is a product of toxicity and exposure. Exposure is usually defined as acute when it is intense for short duration and chronic in case of low level over a long period of time. Control procedure reduce or eliminate the level of toxicity, the dose or both, thereby reducing the hazard or the risk. Now we will see control methods of these indoor air quality contaminants. So we can eliminate at the source, that is source control, a dilution with less contaminated air, that is ventilation, extraction with some type cleaner, that is filtration. Elimination is complete removal of biological agent, toxic substance and hazardous condition. Substitution, the deliberate purchase or use of less hazardous material. Isolation, contamination, encapsulation, shielding, sealing, timing, and the use of distance or all means of isolating a contaminant or a source from the exposure to the humans. New construction or renovation design includes effective ventilation, housekeeping and dust suppression, maintenance and practices, specification for proper work procedure to reduce or control contaminated releases for purposeful reasons such as pesticide need to be spelled out and should be part of the training procedure. Replacing the insulation, carpenting, well carving, etc. Education, training, labeling and warning procedures. Sanitary procedures and personal protective devices, the use of hygienic principle to reduce or eliminate hazardous material from a person may be critical under certain conditions. Filtering and air cleaning. The use of adequate and properly selected filters and purification devices in the air distribution system with outdoor air and mechanically recirculated air is an essential control factor. Ventilation. This is very cost effective method. Through increased outside air or exhaust with controlled makeup air, dilution occurs. Thereby, we are less exposed to the pollutant. Now we will see sick building syndrome. When a building becomes sick, it usually starts with building occupant complaints of discomfort, headache, nausea, dizziness, sore throat, dry or itchy skin, sinus congestion, nose irritation or excessive fatigue. Suddenly, the words that are rapidly becoming the bane of building owners, facility managers and engineers are declared it as sick building syndrome, SBS. Of course, the building is not really sick, but it has developed a condition that can make its occupants uncomfortable, irritated or even ill. Sick building syndrome is a worldwide and complex problem. Initially, it was used to describe a building where a set of varied symptoms were experienced predominantly by the people working in an air-conditioned environment. A building is said to be sick when 20% or more of the occupants voluntarily complain of discomfort symptoms for a period exceeding 2 weeks and affected occupants obtain rapid relief away from the building. So, the things we discussed are described in a single picture. So these are the right side is the source from which contaminants are evolved, which causes the building sick, and bottom line are the symptoms for sick building syndrome, and the top is the reason for the sick building syndrome, like poor air circulation, air tightness, combustion gas generation from the equipment and heating, use of chemical substances for cleaning of floors, ceiling, etc. The symptoms indicate headache, agitation, anxiety, dizziness, sleepiness, psoriasis, palpitations, nausea, cold sensitivity, numbness, easily fatigued, sore eyes, feeling of suffocation, dry sore throat, coughing, backache, intermittent fatigue. An associated problem is building related illness BRI. It is deemed as a building associated clinically verifiable and diagnosable disease. If signs of actual illness are present and can be attributed to the condition in the facility, the building can be classified as BRI. So this tabular column indicates the different building related illness like hypersensitivity, pneumonia, and the attack rate is 3 to 16%, and incubation period is for 6 hours. And we have humidifier fever, which is variable between 2.6 to 70%, and exposure period is 4 hours.